Hello. So today we shall be looking at electric cells and electrolysis. Electric cells and electrolysis. Okay? Without wasting more time, let's dive into this topic. Let's go into the definition of some terms. Firstly, we need to consider what an electric current is. Okay? I would like to take a look at this diagram here. Okay? Look at the diagram. You can see the movement of these negative signs. These negative signs are called electrons, okay, or charge. Now, the movement of charge is called electric current. Whenever charges are moving, then you say electric current is taking place. All right, so that is what electric current is about. It's simply the movement of charge or electric charge in motion. Then another concept we must consider is electric cells, which is our major topic this morning: electric cells and electrolysis. Now, electric cells are just chemical devices which are capable of causing an electric current to flow. We have said electric current is the flow of charge, right? But now the cause of this flow of charge is called the electric cell, device that allows the flow of electric current is called electric cell. All right. Having known that, let's not talk about the type of electric cell that we have. There are two major types of electric cells. We have the primary cells and we also have the secondary cells. The primary cells are those cells that produce current, and after that they cannot be recharged. By the redefinition, we say they are those cells in which current is produced as a result of an irreversible chemical change. So when we say irreversible, that means they cannot be charged again. So the cells that produce current as a result of irreversible chemical change are known as primary cells. And we have three major examples of them. We have the simple cell, which is sometimes called the voltaic cell, named after the scientist called Volta. The second one is the Daniel cell, named after the scientist called Daniel. And the third one is the Leclanche cell. So these are the three examples of primary cells. So these three types of cells are not rechargeable. They produce current as a result of irreversible chemical change. Then the second type of cell that we have is called the secondary cells, the secondary electric cell. Now these are just the opposite of primary cells. These are cells which can be recharged when they run down. So they are cells or electric cells that can be recharged when they run down by passing current backward through them. All right, so that is how they are different from primary cell. Primary cell cannot be recharged. Once they are down, they are down. But secondary cells can be recharged. Of course, we use this secondary cells in some of our gadgets, like our phone, our laptop, our wristwatch, and so on and so forth. So, and this secondary cell too has two major examples. We have the lead acid accumulator, that means made up of acid, and the second one is called the alkaline accumulator or the nickel accumulator. All right. So, in a nutshell, we have two types of cells: the primary cell and the secondary cell. The primary cell are three examples: the simple cell, the Daniel cell, and the Leclanche cell. While the secondary cell also has two examples. We have the lead acid accumulator and the alkaline accumulator. Now let's talk about one of the examples of the primary cell, which is called the simple cell or the voltaic cell, named after the scientist called Volta. This is a typical diagram of the simple cell. The simple cell is made up of, all cells are made up of three components: the electrode, the electrolyte, and also the flow of the charge itself. Now, for the simple cell, the electrode it has is positive electrode and the negative electrode. And in its own case, the name of the positive electrode is called copper. The electrode are just rods that are inserted inside the container, while the negative electrode is zinc. All right. Now, when you connect the positive electrode inside the container having the electrolyte in this case is dilute sulfuric acid, which is known as the H2SO4. When you insert the two electrode, the positive one and negative one, into the electrolyte, there exists a chemical reaction taking place in the combination. And what happened? If you take a closer look at this very well, you will see that hydrogen gas is going straight to this copper electrode. You could see is accumulating the copper electrode, while the zinc is dissolving into the electrolyte. And that is why we could see the electrons moving from the zinc through the wire, and that's what lighting the bulbs, and then it goes again back through the wire again to the positive electrode. That is how the reaction occur in voltaic cell. Okay, so you must know that it has two electrodes, the copper electrode and the zinc electrode, and the electrolyte as well, and the combination of these give us a chemical reaction that produces electric current. All right, having known that, now we can now talk about the defects that this simple cell has. Okay, what is the defect? There are two major defects or problems with this cell. The first one is called the polarization, and the second one is the local action. Now, let us take a closer look at this simple cell again. This is another version of it. Okay, in this case, the copper is on the right hand side and the zinc on the left hand side. Now, what happened here? During the chemical reaction, you could see hydrogen gas going straight to the copper. Now, at the point it will release so much hydrogen on this copper plate that it will now insulate the copper from allowing current to flow, and as a result, the electric cell stop working. This accumulation of hydrogen bubbles around the copper plate is called polarization. So polarization is one of the defects of simple cell, the accumulation of hydrogen bubbles around the copper plate that finally ends or stops the working of the cell. The second problem or defect of this cell is called the local action. The local action occurs as a result of the impurities in this zinc electrode. If the zinc electrode is not a pure one, maybe it has some impurities, these impurities go into the electrolyte, react with the electrolyte, and stop the working of the cell. Now, how can this problem be solved? These two problems. For polarization to be solved, the scientists came up with an idea of using a substance called depolarizer. Depolarizer is now used to prevent the accumulation of hydrogen bubbles on this. Okay, that is the way to solve the problem of polarization. The use of depolarizer such as manganese oxide. So it will depolarize the hydrogen bubbles from this, and it will now allow the continuation of the flow of current. Okay, so that's how to depolarize, or how to prevent the polarization. And then for local action to be solved, a solution proposed, and that is the use of mercury. We call it amalgamation. Amalgamating the zinc plate in a way that the impurities will not have any reaction with the chemical, with the electrolyte, with the chemical reaction in the electrolyte. So by the time you amalgamate this zinc electrode, then local action will be prevented. All right. So I haven't said that on the defect of simple cell. Then let us consider another example of the primary cell, and that is the Daniell cell. Actually, the Daniell cell is no longer in use in our world today. It was It was invented by the scientist called Daniel, like I said earlier. Now, the Daniel cell was invented to solve the problem of polarization. It was his idea that brought, it was the invention that brought the use of the polarizer. Now, Daniel advanced his own cell in a way that he now used two electrolytes. The simple cell only has H2S24, but in this case now, Daniel now added another electrolyte, which is the copper sulfate. Now the copper sulfate now acts as the depolarizer, which help in depolarizing the hydrogen bubbles at the copper plate. That is just the difference between the Daniel cell and a simple cell. The addition of a depolarizer electrolyte called the copper sulfate now help in depolarizing the hydrogen bubbles. So having said that about the second example of primary cell, let's talk about the third one, and that is the Leclanché cell. The Leclanché cell is of two types, the wet one and the dry one. They are made up of the same component, almost the same component. Okay, when it comes to the positive electrode, the wet Leclanché cell has carbon rod, and the dry one also has carbon rod as the positive electrode. But the negative electrode for the wet Leclanché cell, it has zinc rod, but the dry one now makes use of a zinc container. That's the difference there. And when it comes to the electrolyte, the electrolyte are the same, ammonium chloride solution. The same thing with the depolarizer, they have manganese dioxide as their depolarizer. Now there's an advantage that the dry Leclanché cell have over the wet one, and the advantage is that it is lighter. The wet one is heavier because of the liquid, because of the electrolyte that's in form of liquid. But the dry one is lighter, and that is why it has advantage over the dry Leclanché cell. Now, this is all we need to know about the primary cells and their examples. Now, let's go straight to the secondary cell. We have said that the secondary cell are the cells that are rechargeable after they have run down. And the two major examples we have is the lead acid accumulator, which we commonly use in our world today. And the second one is the alkaline or the nickel accumulator. Now, without much ado, I would just like to give a summary of this secondary cell, because we just need to know the summary of it at our own level. Now, for the lead acid accumulator and the alkaline accumulator, their positive electrodes are different. For lead acid accumulator, it has lead oxide or lead oxide as its positive electrode, but alkaline accumulator has nickel as its positive electrode. For the negative electrode or terminal, the lead acid accumulator has lead as its own negative electrode, while the alkaline accumulator has either calcium or iron as its negative electrode. And thirdly, for the electrolyte, the lead acid accumulator has dilute H2S24, or what we call the sulfuric acid, as its electrolyte, while the alkaline one has the potassium hydroxide as its electrolyte. Okay, so we've been able to see the type of cells, electric cells, and their examples. Now, the secondary cell, I will also want to mention again that they have the maximum voltage that they can contain, and that is 2.2 volts. 2.2 volts for lead acid accumulator, while 2.0 volts, or sometimes also 2.2 volts for the alkaline accumulator as well. So having said that, may we now go straight to the other side of our topic, which is electrolysis. Okay, all that we have been seeing in the electric cells is about electrolysis. It's just the process whereby liquid, which is electrolyte now, conduct electricity. So the conduction of electricity by the electrolyte is called what? Electrolysis. So a process whereby a liquid conducts electricity by the movement of positive and negative ions within the liquid while undergoing chemical changes. Okay, and this is just a typical example of electrolysis occurring. You could see that the electrolyte in this case now is copper sulfate, is conducting electricity because the copper has now ionized and become copper ion, while the H2SO4 has also ionized and become sulfate oxide. You can see it here. So these ions moving about is as a result of what? Electrolysis. Okay, now electrolytes are of course liquid that can conduct electricity, while the non-electrolyte are liquid that cannot conduct electricity. An example of non-electrolyte are distilled water, alcohol, sugar solution, liquid, paraffin. Now let's talk about the law that governs electrolysis. This law is propounded by a scientist called Michael Faraday. He actually propounded two laws of electrolysis. And the first law states that the mass of a substance liberated during the process of electrolysis is proportional to the quantity of electricity passed through the electrolyte. Okay, now if we go back to our previous diagram here, you see that the copper is gradually producing some masses as a result of electricity occurring. So Faraday is saying that the amount of mass that is being released by this substance or by this electrode is dependent on the amount of electricity that is being produced. In other words, the more electricity produced, the more the mass produced. That is the first law. The second law, it now states that this mass also is dependent on the electrochemical equivalent of the substance. In other words, the higher the electrochemical equivalent of the substance, the more the mass. So that's the two laws that Faraday propounded. So let's go back to the law again. So the first law states that the mass of a substance liberated during the process of electrolysis is proportional to the quantity of electricity passed through the electrolyte. And the second one now states that the relative masses of substance liberated by the same quantity of electricity are proportional to their chemical equivalent. Okay? Now by equation, we now say M equals ZIT, where the M now represents the mass of the substance, the Z represents the what? Electrochemical equivalent, and the I represents the electric current, the T represents the time taken for the electricity to occur. All right, so this is the law being summarized in that equation of Faraday's law of electrolysis. All right, now let us now talk about the area of application of electrolysis. First one is applicable in electroplating metals. Electroplating just means coating a metal with another metal. It's only through electricity that this can occur, using electroplating of metals. It's also used in purification of metals, and lastly in the production of metals from compound. So these are the three areas of application of electrolysis. All right, so we shall be drawing the curtain here. In our next class, we will learn more on this concept. So thank you for listening. Bye for now.